Okay, so I'm looking for representatives from Sharkbait, Aquaholics, and Seahorse Rodeo Cow people, boys and girls. So if you're one of those, please identify yourself if you're going to be the presenter of the slides, and I'll go ahead and set you up as co-presenter. So Sharkbait, do you have a representative online, please? Sharkbait, calling Sharkbait.
Hi, sorry. Yeah, Casey's going to be our presenter.
Who is?
Casey.
Is she online? I don't see her.
Let me see.
Only 12 of us, unlikely.
Okay.
It might be Spencer. It might be under Spencer.
Okay.
Oh, a lot of them can't find the link. That's why, to get onto the Zoom class.
Well, it's the same link it's always been.
Yeah, hold on. Let me share it to them.
Okay, what about Aquaholics? Is there anybody from Aquaholics?
I will be presenting for Aquaholics, Jared Patch.
Okay, you are now co-host. And we'll be starting in 5 minutes. So if Sharkbait hasn't logged on yet, then you, okay, Sydney, are you going to present for Sharkbait?
I'm not part of Sharkbait.
Oh, okay. Somebody said Sydney was part of Sharkbait. Excuse me.
Maybe another Sydney.
For me, another Sydney. Okay. All right. What about the seahorses? Are the seahorses here online? Seahorses. Seahorses. Wow. Attendance has really fallen off a cliff here. 4 minutes to go.
I'm Sharkbait and I'm going to be screen sharing.
Okay. Sorry, I don't see your. All right. Spencer?
Yes.
Great, Spencer. Okay. So you're now a co-host. Go ahead and get your slides open and in presenter view. And then when we start here, I'll give you a signal and then you'll go ahead and start share your screen. But wait until I signal you, okay, please?
You got it.
Okay. All right, so I got Sharkbait and Aquaholics set up. I'm still looking for the seahorses. Who is here from the seahorses? Seahorses. Okay. All right, let's go ahead and get started for class today.
Are you being serious?
No.
Why are we second? Why are we second? Oh, we're first.
Okay. So it looks like I've got 36 folks online. And I still don't have anybody from the Seahorse Cowboys. If you're from the Seahorse Cowboys, please notify me right away so we can get you made into a co-host and you'll be able to.
I'll be the co-host for it, Emma Steiger.
Okay, Emma, let me see. All right, great. All right, so please get your, what you should do with your computer is to have your, you have your presentation loaded up. And then when I give you a signal, you'll go into presenter mode and then share your screen. Do you know how to do that? So there'll be a little icon on the top of the thing and you do share screen. All right. Okay, and then some notifications. I just posted an announcement about the final exam schedule. So the final will be, next week is finals week. And so the final exam will have the same approximate format as the midterm take-home exam. So the final exam will be an entirely take-home exam. It will be multiple choice and true-false questions, and they'll be given via Canvas in the same mode as the quizzes. And I think I can make it all in Canvas. If there are any diagramming questions, it may be necessary to do an upload, a file upload. So you might have to scan something and then upload the file. So there'll be a lot of questions, just as there were on the midterm, but you'll have from Thursday evening at midnight until Tuesday evening at midnight. So midnight on Tuesday, all day Tuesday, to answer this exam on Canvas or to complete the exam on Canvas. You will not be able to see the correct answers until you finish the exam, but you will have unlimited time to respond to the questions. And there will be hints in some cases, not in all cases, about where to find the material. The exam questions will include questions taken from the presentations that have been given by the different teams. So that'll be comprehensive. And plus there will be questions over the material that I presented in the lectures once we started doing the online lectures. So before we start, are there any questions about the exam format? Please go ahead and make yourself known, unmute yourself and ask the question. Any questions about the exam, please?
Will it all have to, oh, sorry.
No, you're good.
Will it all have to be done in one sitting or will we be able to come back to it?
No, you will be able to come back to it. And I'm not going to make it all do. And that's what I was trying to explain. You can't look at the answers, but you can stop and come back. And so you don't have to do it all in one sitting. It's just the same format as you had on the midterm take-home, where you had unlimited time. So I'm not going to put any time pressure on anyone, but there will be a lot of questions. So just prepare yourself for, a long session, some long sessions with, going over the material, the lecture notes, the presentation notes, the textbook, and you'll be able to answer those questions.
Thank you.
Other questions about the final exam?
Yeah, I was wondering if there was going to be a study guide like there was for the midterm.
A study guide? No, I'm telling you now, no, there's not a study guide. This is just, the questions, and there'll be hints in the questions about where to look for, material on those questions in most.
Oh, okay.
So I'm not going to do a study guide for that. You'll have it built into the exam, so to speak.
Cool. Thank you.
Okay. Any other questions?
What do you mean? Oh, sorry. What do you mean when you said that we might have to scan some things in? Like, can we take a picture with our phone and send it in?
Yes, you can. And of course, you want to take a good picture, with good light and straight angle. But yes, that would certainly be possible to scan something with your phone, take a picture and send it in if there's a requirement for a drawing, a diagram.
there's an app for anybody that needs it. It's called DocScan, and you can get like the most clear picture of any document that you want to send in.
Yeah, there's a couple of apps out there. There's CamScan, there's a bunch of them, and they all basically do the same thing. They take your picture and then they kind of, adjust it so that it's a square profile or a rectangular profile, and they, a lot of them will, filter it so it's easy to read. And so that's the best way to go. Thank you, Lindsay. Okay, any other questions? Anybody, and if you're having difficulty, if anything has come up for you, if your health is, a problem, let Carrie or me know privately, and we'll try to accommodate everybody. We want to make sure everybody gets through this. And looks like we got about 52, 51 people. So I'm going to ask Sharkbait at this point. I'm going to stop sharing my screen, and I'll ask Sharkbait to please make their put it into presenter mode and start sharing their screen, and then take away the presentation.
All right, you got it. Oh, all right, we're ready.
Okay, so our team is Sharkbait, and I'm Maggie, and our presentation is the future of oceanic Should I wait till he gets back?
Oh, he left.
Wait, who left?
Okay, I'll start over. So we're Team Sharkbait. I'm Maggie, and our presentation is the future of oceanic alternative energy sources in North America. As climate change becomes increasingly prevalent in recent years as a result of human activities, perhaps the most well-known being the burning of fossil fuels for energy, scientists have been searching for new ways of generating energy that does not have adverse effects on the climate nor the environment. One of the methods of generating energy that has come into practice in recent years is the conversion of the ocean to marine energy. This has been one of the main ways that people have been trying to reduce carbon footprints through energy production. And it's also one of the cleaner ways to produce energy. So Casey's going to cover trends, predictions, and uncertainties for the future of oceanic alternative energy. I'm going to cover the relevance of alternative energy sources and how it impacts us as Floridians. Megan's going to talk about the history and recent developments and also cover economic effects. Rosie's going to go into detail about tidal wave energy and how it affects the community. Alex is going to present the methods and materials related to alternative renewable energy. And Alex is also going to talk about how climate change is pushing the world towards cleaner and more reliable sources of fuel.
All right, so these are the four main types of oceanic alternative energy sources that we're going to cover in this presentation. Wave energy is a massively powerful source of renewable energy, and it isn't quite utilized to the strength that it could be because there is so much coast in the United States that have extremely powerful waves. Another thing is offshore wind energy. It's the most advanced source of offshore energy in the US and provides a heavier and steadier supply of wind compared to onshore due to the temperature differential of land and sea. One of the main reasons it's not used is because it's not a very attractive option, and some people say that it's dangerous to birds. Another energy source is tidal energy. As the tides move in extremely large quantities of water across the Earth's oceans, tidal energy provides predictable and steady power. And then last but not least, biofuel. The conversion of microalgae to biofuel could eliminate our use for fossil fuels. And it also lowers the amount of CO2 in the air.
So the history and recent developments of alternative ocean energy. The Energy Policy Act was passed in 2005, which put regulations on companies for pollution. It pretty much gave a clean energy standard. And lots of changes have been made since then. A lot of states have signed for 100% clean energy by either 2030 or all the way up to 2050. Tidal plants, which is the bottom photo, I think that's in France. They look like that pretty much, and then have turbines in the water, which are powered by the change in tidal motion. We don't have any in the US. It's partly due to the cost, because all of this is relatively new technology. And placement, it would have to be put on protected land, or land that would have to be monitored. There is a thing called I don't know if it's TideGen. I don't know if that's how you say it, but that's how I'm going to say it. It's a device located in Maine, which according to ORPC is the first revenue-generating grid-connected tidal energy project in North America. And it's the first to deliver power to a utility grid, and that was put into place in 2012. So that is the closest thing we have to a tidal plant in the US. As far as wind energy, there are not any for offshore in the US. There's one in Denmark. It started operating in 1991. So that's when that started. There is some space being like that in South Carolina that could be used for offshore wind in the future. Next slide, please.
All right, so another version of alternate energy sources is the ocean thermal energy conversion system. It started in Hawaii, and it's practiced a lot in small islands. But basically, solar energy from the sun, it heats up the surface of the water at a different rate than the much deeper water. So it creates the temperature differential that we've learned so much about. And this temperature differential can be used to create energy. The vaporized fluid drives a turbine generator. The vaporized fluid is turned back into a liquid in a condenser cooled with the ocean water. And the system uses seawater as the working fluid and can even create desalinated water. Since 2015, the OTEC has been used at the Natural Energy Laboratory of Hawaii Authority to power a 150 kilowatt hour plant that supplies power to a local grid. There are many more OTEC plants in the works, but again, it's mainly for small islands. And it doesn't create too much energy, and there's been a lot of issues with the energy laboratory in Hawaii. It also creates upwelling and redistributes the nutrients of the ocean, which isn't great for sea life.
So Florida's surrounded by water on pretty much every side. We've got like the Gulf Coast and then the Atlantic Ocean on the other side. So there's a lot of potential there for water-based alternative energy sources, especially because there's really not super powerful current flowing along through the coast near the Atlantic Ocean. It's the Florida Straits Current on the East Coast, got the power of a gale force wind. And so because the water is heavier than the air, it converts the water to energy with the same potential as wind energy. So it's really efficient. And also the Gulf stays pretty warm year round. So that also helps create more energy. And the Southwest National Marine Renewable Energy Center really believes that ocean energy could replace nuclear and fossil fuel plants in the future, which would be a really big step as far as alternative energy sources, as that's kind of what we rely on most now. If you want to go to the next slide. So in Florida, there's kind of two trains of thought of whether you support or don't support offshore energy, because a lot of Floridians were impacted by the BP oil spill in 2010. So people really got to see firsthand how important it is to find more reliable and safer energy sources. And also creating ocean energy plants would create a ton of jobs for local communities, boosting the economy and helping unemployment rates. But a lot of people view the power plants as eyesores, and there's a huge tourist economy in Florida. So if people, have a home down in Miami that they rent out, they're probably going to be impacted if people, they want a view that's untouched. They don't want to have to see like a big ocean power plant outside of their view if they're paying thousands of dollars for that house that they're renting. So there's really just a bunch of reasons why people would or wouldn't support the use of ocean energy. Can I go to the next slide?
So this graph here, this is showing the economic factors, the summary of projected economic impacts of electricity generation to 2020. This graph is showing the comparison of wind and natural gas. This is actually data from a source that was talking about wind in Colorado. So this is not offshore wind. However, it still is a good representation of the difference between just wind energy in general and natural gas. So one of the major differences is the capacity that wind holds compared to natural gas, as you can see in the second column, and the jobs. So the 1-year jobs and the long-term jobs are higher with wind energy compared to natural gas. The tax to local governments is a little higher with wind energy. Also, this is based on wind energy that is on land. So I don't know if it would be different for landowners in taxes if it was in the ocean. I don't know how that would work out. But, it also saves a ton of water with wind energy because of the water that's being used with the natural gas running. So as I said, it creates a lot more jobs, and offshore wind is new. It's a new technology, so it is more expensive just because of the unknowns, and it's harder to take care of and upkeep. There is a possibility of gearless wind turbines, which could decrease the maintenance that is needed.
Alrighty, so I'm going to be going over in detail a little bit more about tidal wave energy. It's called either tidal power or tidal energy, and it uses the use of ocean tides to create electricity. It is a major source of renewable energy, but it is very early on, although there are power plants that have been around for a couple of decades already. It's not a widespread thing as of now. And basically, we don't fully understand the effects of the community on it yet. There's not a lot of research, but we do know it is a potentially good place to harvest energy and for when our fossil fuels do deplete. Tidal power can actually produce approximately 700 terawatts an hour of energy a year. So it's a lot of energy potential, but the issue is that there is not enough space, or most people or countries like the US do not want to take apart and put in place miles and kilometers of space to build these power plants. Another great thing about tidal wave energy and why it should be looked at even more, it's because it doesn't have greenhouse gas emissions. Also, these tidal power plants are known to be very extremely durable, and in return creates cheaper electricity because of the lowered fees and maintenance of the place. So basically on the side here, I have a little diagram of what usually is put in place when you want to harvest tidal energy. And it's basically a tidal turbine, and you see that the waves actually cause the propeller to move and create energy. So that's basically it for this slide. Spencer, thank you. So on this one here, I actually decided to put first of all, the world's biggest one, which is the one in South Korea. And this project costs around $355.1 million, which compared to the one above it on the UK, they have an estimated budget of 1.4 billion. So these projects are extremely expensive to build and manage. So, but there is a lot of power. On the Tidal Lagoon one in the UK, it's saying it's going to take up about 9.5 kilometers of seawall. And then they will have to cut off about 11.5 kilometers of sea. So it is a lot of space that you're looking at when you want to do these power plants. And that is why there's so few, and why there are only certain amounts all over the world. So there's, I think, maybe 5 or 6 actual giant power plants that are working right now. But they do have the potential of creating a lot of energy. Next one. Thank you. So one of the biggest issues as well is the potential disadvantage is that you could ruin its, habitats, like for plants and animals. There's a lot of issues there because it could create a lot of turbulency which creates all that matter, all the sand to move around, and we don't know how that's going to affect ecosystems as of now. They're also known to have an effect on navigation and recreation. So basically, you wouldn't be able to use that amount of sea or anything like that because it is obviously a power plant. But the huge benefits of it, again, are that it is a renewable energy source and it's very clean. It doesn't emit the greenhouse gases that all our fossil fuel burnings does, and so forth. The United States doesn't have any tidal power plants, and that is actually mainly because we don't want to take up the space and we don't want to invest the money into it. That's basically the biggest issue. So a few of the sites could be found in France, England, Canada, and Russia, and they have much more of a potential to use tidal power than us. Tidal energy is also very expensive and requires a lot of sea space. So you have the economic factors again, and which to me in a couple of years, it's going to be, the expenses paid now will be better. But again, there's not enough space, or we just don't want to, as we said previously, people don't want to see a giant power plant outside their, their very expensive beach home or anything like that. So yeah, those are basically the impacts right now.
Few methods of energy conversion that I decided to go into depth about were the power plants that we've talked about already a lot, and converting microalgae to biofuel. That one's probably the most interesting that I find personally, because it's just not that talked about. I hadn't heard about it until I started doing this project. So with the tidal energy, I'm just going to go into like the testing methods and how the water actually produces the energy in the machine. So basically the waves and tides rotate a power generation turbine inside of the plant that when the pressure in the system reaches a critical point, starts to generate energy, and that can be directly used to power marine equipment like lighthouses and navigation systems. And testing starts in super small tanks with simulated waves, sort of like wave pools at a water park. And then they start to move to like secluded parts of the ocean that don't have a lot of risk for endangering any animals or causing any destruction with marine plants or anything like that. Converting microalgae to biofuel is sort of in its testing stages still, but the potential for this industry is growing because scientists see so much potential in it being able to completely replace diesel fuel in the future. You can go to the next slide, actually. So it's such a great alternative energy source because it has the ability to use CO2 for during its metabolic processes, which takes the CO2 right out of the atmosphere rather than releasing it and warming the environment more. So with climate change at an all-time high, all of the greenhouse gases, you would think that people are trying to use less, but according to one second. My internet connection is really bad right now. It's just like reconnecting. It won't even let me see anything. So.
We hear you fine. Just keep talking.
Okay. So in the past, crops have been used to generate biofuel, and the problem that they found in this, when it was mixed with diesel fuel in cars, it started to corrode the engines of these cars. And the difference between that and the microalgae is that it hasn't been shown to corrode the engines, and because it has a high photosynthetic capacity and large biomass of production, it's just a more efficient way to create fuel, and it's so highly recognized by scientists because it would completely eliminate the need for fossil diesel in the future. You can go to the next slide. So how is climate change pushing us toward renewable energy? So, according to the most recent IEA data, fossil fuel energy combustion has only decreased by 5.3% in the last 42 years. And that's just because of the slight increase that we've seen in clean energy like solar energy and hydro energy and other things like that. But it doesn't fully eliminate all the need that we have for the burning of coal and other fossil fuels. So, for example, like global emissions of CO2 have doubled, natural gas production has tripled, and coal production has doubled since 1973. And so you can see that we're using more when we should be using less. And this is just increasing and speeding up the whole climate change process. It's making temperatures higher. And so all of these factors are sort of pushing us to find an alternative energy source that won't produce these adverse effects. So if we don't convert to one of these methods like biofuel or power generation turbines, or just we have to use all of these methods together in order to completely eliminate our need for all of the other fossil fuels that power everything that we need to just live. So also according to the IEA, crude oil and coal are dwindling and they're projected to be completely drained within the next 70 years. So this change from non-renewable energy to renewable energy, it needs to be seen within the next 50 years if we want to be a working country or working world with this alternative energy source and without the need for the crude oil and fossil fuels and coal and everything like that.
So to conclude our presentation, the overall use of marine energy would be better for our environment and for the future of our planet. And while we haven't progressed this far compared to other countries, the U.S. Department of Energy has been leading new projects. Like we talked a little bit about Hawaii. There are a lot of prototype projects, like in North Carolina State University is developing integrated enumerated models and water experiment prototypes for an energy harboring ocean site system. Texas A&M University will develop and test a scaled prototype of its surface riding wave energy converter, and it will be ready for OpenSea testing at the end of the project. And here in Florida, FAU will develop and prototype a low-flow marine current turbine to provide partial power to recharge battery banks on board and unmanned mobile at-sea recharge stations. So although energy sources have their own challenges, those issues pale in comparison to the damage of fossil fuels and other energy sources commonly used. Overall, oceanic alternative energy sources are a great step forward to a cleaner energy in the future.
Right, and here are the sources that helped us create this presentation. All right.
Okay, any questions from the audience? Okay, well, I had a couple of questions. What steps have to be taken in terms of offshore energy development for the tidal and the wave energy to prevent biofouling? And what is biofouling, and why would that be a problem for offshore energy? Anybody from SharkBait could answer that.
So biofouling is basically when some kind of like underwater structure kind of gets ridden by barnacles and other kind of organisms that like fix onto stuff like algae, and that could kind of damage the technology used to generate energy. Like it could get in the like the turbines and all that. So you would have to find some kind of alternative to maybe like a different type of material being used to build it, or just expect regular cleanings, someone getting down there and scraping off barnacles.
Okay, so that's an issue then for tidal and wind energy, tidal and current energy. You said that there's not much information about offshore wind. what can you tell me about the offshore wind industry in the North Sea in Europe?
I just focused on the United States, really, so I didn't get much information on that.
Okay. Well, all right. How about the offshore industry in Cape Cod in New England?
I'm not sure about that.
Okay. And how about the Bureau of Ocean Energy Management, which is currently leasing offshore real estate for wind energy?
The only one I saw was the one about South Carolina, where they're looking at that area.
Okay. Well, there are currently offshore wind turbines off Cape Cod. And there are many others that are planned. I believe there are currently some off Texas. So I think it was not entirely correct to say that there's nothing in the United States. In Germany, they have sometimes they generate between 25 and as much as 50% of their energy to their grid comes from wind energy, and a big component of the wind energy are the wind farms, wind turbines in the North Sea, where they have literally hundreds of very, very large wind turbines offshore. One of the features of offshore wind turbines is that they can be much, much larger than they are on land, and they are generally less damaging to seabirds and, birds, and certainly bats, who are a major vulnerability to wind turbines in the offshore environment. So the offshore environment is good, reduced impact to wildlife. I wondered about, in terms of the bioalgae, what is actually being generated? You said that the biofuel from crops like corn, for example, that was corrosive to car engines, but that's the alcohol. So for corn, for example, and other types of crops grown on farms is converted to alcohol, and that alcohol is added to fuel. As if you put gas in your tank, it says up to 10% ethanol in the fuel, and that does cause issues with corrosion. But is that what's being produced? Is it alcohol which is being produced from because it says here biodiesel?
So from my understanding, just the chemical composition of microalgae in comparison to like crops that grow on land is that I honestly I read a couple resources about it, and from my understanding, it just creates less alcohol composition in comparison to the the fuel of crops, so it doesn't corrode it as much. And I think it's something to do with the oxygen content in the microalgae. So yeah, that's pretty much all I know about it.
Well, the great thing about algal fuels, whether they're done in the ocean or in ponds on land, is that algal cells, the cell walls and the lipids in algae, can actually be converted almost directly into a product that's very, very similar to diesel fuel as opposed to alcohol. So diesel, of course, is a major fuel need for trucks and things like that. So that could be an important source of supply. I guess I would have been good to have a little bit more information on that. Let's see, other questions. Oh, I did have a question. So do you think that the tidal energy generating wave energy, that they need to take into account sea level changes? How will that affect the potential for tidal energy?
Absolutely. I think the more offshore that you can, I'm sorry, you can go.
Yeah, okay. I definitely do think that's going to be an issue, and I think that's why there have been so few locations where this energy has been harvested. And the ones that have been there, the biggest one right now in South Korea was because they already had that area already taken about, and they already knew that they were going to get consistent energy from that area. But to do that in other areas is a little bit harder, just because you need the space as well. But the sea level rises and lowering, that's why there's so few. I feel like from what I gathered was that they built where they know it's consistent and where they could
get that energy.
Oh, you're fine. Don't worry. You're fine. You're good.
I don't know if anyone else wants to add to the group about that because I know we all researched a little bit.
Okay, well, I think we have enough there. We'll probably move on. Thank you, Sharkbait, for your response there.
Thank you.
And so I appreciate your effort there. Can you stop sharing your screen? And the next up would be the Aquaholics. So Aquaholic presenter, please start sharing your screen and go into the mode there. All right, I'm starting your timer now. Go ahead, Aquaholics. Make sure to unmute yourself.
So our presentation is on hurricane and storm surge impacts to the environment and the possible methods of mitigation for hurricanes and storm surges. So we see here that hurricanes and storm surge are very prevalent to us, located in Florida and also southeastern United States. We can look just a year and a half ago how Hurricane Michael came roaring up the coast here and came landing at a Cat 4. So obviously this is an issue that is very near to home because it's something that's important to us because it causes so much devastation in our region. We can see that hurricane and storm surges, there is a difference between the two. The hurricane is the actual wind, thunderstorms, the atmospheric issues that arise, while the storm surge is the water that is brought in from the winds of the hurricane. And that storm surge will add to the tide that is currently there. So then it can rise up to even 30 feet, creating storm surge as the more deadly of the two forces that come when a hurricane comes. In addition, our research goes into kind of how far the impacts hit. It's not just people and infrastructure that's damaged, it's also the environment. Trees are uprooted, trees go down. You also, as was talked about earlier in presentations, the coral reefs will get damaged by them on occasion. Not as much of an issue over here, but it does happen. So some of the main focus points of our research was the historical side of it, kind of looking at the formation of hurricanes in addition to a hurricane that's been well documented, just to get some more facts and figures on them. We see some of the impacts of it, how far they reach, and how it adds up. Then there's the innovation, and we're going to cover more or less the mitigation methods and like what's being done to help track them, what methods we can do to track them, and then recommendations. The historical side will be covered by Melissa. The innovation, the impacts is covered by Peyton. The innovations are covered by Brandon and Sam. And then our recommendations are going to be covered by Delaney.
Okay, so hurricanes need three variables to begin formation: warm ocean water, moist air over the surface, and light upper level winds. So how it forms is that moist air over the ocean surface gets warm and rises, generating a low pressure area near the surface. Surrounding colder air fills in any of the gaps left from where the moist air rose. This air also gets warm and rises, creating a pattern. Warm air then cools off and begins to form clouds while the system starts to spin from light upper level winds and continually grows, producing a hurricane. There are 5 categories of hurricanes, and they're categorized using the Saffir-Simpson hurricane wind scale. Category 1 is 74 to 95 miles per hour, 96 to 110 miles per hour for a Category 2, Category 3, 111 to 129, Category 4, 130 to 156, and a Category 5 with 157 miles per hour winds and higher. And obviously, as the categories go up, the damage increases. And with a Category 5, areas almost become uninhabitable at that point. Next slide, please. So the most costly hurricane to date in the U.S. with the most damage and prevalence in the southeastern region of the U.S. is Hurricane Katrina. It was a tropical cyclone that hit the southeastern portion of the U.S. on August 23, 2005. It first started as a storm in the Bahamas and slowly grew into a Category 1 hurricane when it made landfall between Miami and Fort Lauderdale. It only lasted in Florida for like 8 hours, but soon after increased in strength to a Category 3 once it hit the warm waters of the Gulf of Mexico. When it made landfall in Louisiana, it reached a Category 4. Hurricane Katrina then headed northeast and made landfall in the Pearl River. So although the hurricane didn't directly hit New Orleans, the city began to flood due to the overtopping of the levee system, which controlled the water levels of Lake Pontchartrain and Lake Bjorn. Next slide, please. So the most damage we're seeing like in the Pearl River and obviously New Orleans. So in Pearl River, a storm surge of around 26 feet damaged homes and resorts in the coastal cities of Gulfport and Biloxi, Mississippi. The vegetation reached below average density and health, with the worst areas being the bottomland hardwood forest. And then in New Orleans, with 20% of the city underwater, people were ordered to evacuate or to seek shelter by the mayor. However, tens of thousands of people did not take action. And by the next day, 80% of the city was flooded, with everyone at this point seeking shelter, help, and the issues of the lack of food, potable water, and sanitation created a big public health emergency. All the water was finally pumped out of New Orleans 43 days after Katrina hit. And in total, the hurricane caused over $160 billion worth in damage, and the population of New Orleans decreased by a value of 29% between the years of 2005 and 2011. Next slide, please.
Okay, so I'm going to be speaking about some of the environmental impacts that come from these storms. And the first thing is damages from the storm surge and hurricane can have environmental impacts stemming from the destruction of these facilities, such as gas stations, heavy industry, hospitals, hazardous waste facilities, electricity plants, and farms. And the destruction of these facilities listed can lead to environmental impacts from potentially damaging substances stored at these facilities, such as fertilizers, pesticides, herbicides, human or animal waste, asbestos, plastic, oil, gas, and hazardous waste. Next slide, please. And additionally, there is usually a large economic cost of recovery associated with these storms. So it varies depending on the hurricane frequency of that hurricane season, the intensity of the hurricanes, the specific areas affected, and other varying factors because no two hurricanes are alike. So in estimates of economic damage varies. So for instance, Hurricane Katrina had an estimate of $250 billion worth of damage in 2005, whereas Hurricane Irma in 2017 only had 50 billion. Additional 47 billion damages out of the total hurricane damage expense is expected to be attributed to climate change and coastal development in the next few years. So that means along with like the pre-existing damage just from the baseline hurricane. And additionally, there's a loss of life impact that varies on those factors as well. And in 2017, 0.4% of the US population lived in areas with high probabilities of hurricane damage. 4 hurricanes in 2017, for instance, had a death toll of 3,260 people. And hurricanes disproportionately affect vulnerable members of society. So most of these deaths are attributed to loss of life and to drowning. Next slide, please. And finally, the biodiversity impacts. So these impacts are created by many different factors, and it depends on the different factors of the ecosystem, such as pre-existing ecology, biodiversity, and the intensity of the hurricane. And the first major one is wind. So wind impacts these migratory bird routes, and it can injure migratory birds. As we said, the winds can get up to 175 miles per hour. The second thing is currents and offshore impact. Hurricane Andrew, 9 million fish died in Louisiana, 182 million fish died in Florida, and this is due to redistribution of the water column and sediments being stirred up from the storm. And additionally, going along with that, an increase of pollutants and runoffs, like I said, the facilities that get damaged and introduce harsh chemicals and dangerous chemicals into the environment. And lastly, habitat damage from storm surge, heavy rainfall, and strong winds, which can completely change the ecology of an area for vulnerable species. Next slide.
Okay, so hurricanes are costly disasters here in Florida, and people and organizations are always coming together to come up with new innovations to limit the loss of human life. Some ways of doing that, government, officials come up with better warning systems, and that includes public outreach and education programs like HAT, which is the Hurricane Awareness Tour, and that's conducted by NOAA annually. Another way is local city governments are issuing potential storm surge flooding maps, like the one on the picture to the right, that depicts, the areas that are most at risk for storm surges and how high the water could reach. And then in 2016, Congress and the government, they approved additional funding for research to detect and issue tropical storm warnings before the formation of even a cyclone. People are also coming up with more uniform requirements for evacuations to, ensure that they are done efficiently as possible. Government organizations are working together with, state governments, local governments, with resources to improve evacuation planning and responses. There's also the NHP, which is National Hurricane Program, and they assist in evacuation studies and provide timely guidance for emergency city managers. And there's also the HLT, the Hurricane Liaison Team, which supports operations by ensuring the exchange of information goes as smoothly as possible, so everyone can evacuate. Another interesting fact I found was hurricane research done by FSU in the early 2000s. A meteorologist by the name of T.N. Krishnamurti led a group to develop the FSU Super Ensemble, which combines an output of collection of different information for different hurricane models to ensure that everyone's got the best information possible. Next slide.
All right, so I'm going to talk a little bit about how we track and prepare for these storms. First of all, the NHC tracks these storms through satellites, radar, ships, buoys, and reconnaissance aircrafts. Primarily, we use satellites and dropsonde technology. Once the hurricane has begun to look as a threat, U.S. Air Force and NOAA also will step in. This is where they use the dropsonde, and it's basically functions as a weather balloon, except it's falling downwards. It records wind speed, humidity, air temperature, pressure. This tool records the data twice per second, and usually for about 10 to 15 minutes, depending on the elevation it was dropped at. This tool is going to bring a more accurate reading since it's in direct contact with the storm, and it should be an important piece of equipment in figuring out why these storms are happening more frequently and with much more intensity. Next slide. Hurricanes are also a big reason for why building codes continue to grow more strict. The hurricane known to influence our mitigation process the most probably was Andrew, especially in Florida. That happened in 1992, and it created $27.3 billion worth of damage. It also created Florida's worst insurance crisis in history. So that led to the reform in 2002, Florida's building code, and it was developed to supersede all local government building codes. It included building advancements like higher elevated homes, hurricane-proof doors, windows, hurricane straps, hold-down anchors. And overall, the price for construction is only about 15 to 30% addition on top of what it used to be. Overall, that's going to be a whole lot of savings worth covering a new home. A prime example of this being effective is the picture I have right here. This was Hurricane Michael, and you can see the destruction around the one home that looks like nothing happened to it. That home actually went above and beyond the current codes. The current code is for 120 mph, and this one did 150. That's a good detail because 120 is a category 3, and you would think it'd be primed to suit for category 5. You want to be prepared for the worst. So next slide.
So some recommendations that we have made is one, to enforce stricter construction codes and limiting the construction in coastal areas that are more vulnerable to the storm destruction. And this examples of this would be building houses at higher elevations and being better prepared for the aggressive waterfronts. And the 2000 International Residence Building and Florida Building Codes are examples of these laws that have a purpose of lessening the potential destruction and amount of lives lost during a storm. We also should implement and regulate public outreach education programs that are held by the NOAA, as it'll encourage members of society to be aware of how to prepare for these storms, because that's the most important thing in order to minimize chaos and panic and when an emergency were to happen. We should also develop potential storm surge flooding maps that can accurately predict where the most high-risk areas are when a storm is approaching. Being able to predict the most high-risk areas during an emergency is really important, as it allows us to be aware of how to prepare for a storm or possibly evacuate in the most efficient way. And like the fact that these maps tell you how high the water is going to reach and gives you important information on how dangerous the storm is going to be, that'll allow the community to decide what degree of precaution that they should be taking. Also, controlling the production of harmful products such as pesticides and all of that would obviously prevent further damages of the gas stations, hospitals, and things that is essential for everyday life for our society. Next slide, please. Federal organizations such as the National Hurricane Program also collects resources to develop evacuation tactics and response tactics, as having these tactics that are universally known by the community is really important, as keeping as many people as safe as possible. And also just having a really good exchange of information between the different government branches is really important, as communication is what keeps the system functioning properly and effectively. Storm tracking and knowing when a storm is going to come is also extremely important, because that's the most deciding factor when considering the amount of preparation that should be taken. But overall, the goal of these recommendations is to properly prepare for the best we can for a storm in order to keep the most amount of people safe as we can. Okay, next slide.
So in summary, some of the main things that we need to remember is the hurricane formation. It requires the warm ocean water, the moist air over the surface, and the light upper level winds. There's 5 categories of the hurricane, 1 through 5. If it's below that, it's either a tropical storm or nothing. And hurricanes damage lives, properties, and this is what led to the new codes and regulations being required. And this is from Hurricane Andrew that caused that. But there's still a lot to be done, such as was recommended, we need to inform people better about where the hurricane's going to hit, the damage it will be causing, and just leading to more informed public. That way they can make the informed decision to keep themselves safer. In addition, another summary fact would be that the impact leads to environmental, even just because of us, not from the hurricane. As the factories, gas stations take damage, there can be the runoff that will impact the environment as well. And then lastly is the impact is not just us as humans. It's to the environment, it's to the economy, it's to the whole biodiverse nature of our planet. And then our references. That is all, unless you have questions.
I have a question.
Yes.
I know you guys were talking about like hurricane preparations on private property, like windows and roofs. Do you guys have any recommendations for like public property, so like roads or parks?
My response to that is they're also going to be covered by the building codes of Florida. So when roads are being built, when public infrastructure is being built, from sidewalks to roadways to parks, they still have to follow those same building codes that are applied to personal property. But the advantage with personal property is they as an individual can go up to the next level, while when it is public, we're typically kept to the minimal level due to funding and price.
I think something also important that public, like parks and public areas, would want to implement would be proper like sewage and draining facilities that could aid flooding and storm surges and stuff like that.
Thank you.
Okay, just a couple of quick questions and then we'll move on to the next one. Did you explain, the factors that can increase or decrease the amount of storm surge from a typical hurricane?
We didn't specifically address that, but what some of the issues would be is looking at just water height. So if it's high tide, the storm surge is going to be higher then because the water's already higher. Low tide is going to be lower. In addition, take into account the moon and sun's position and how that will affect the tide. Those will all affect the height of it. But mainly the storm surge is going to be impacted by your closeness to the ocean, whatever waterway is there, and the category of the storm, as it's mainly the winds that's pushing the water in that creates the storm surge.
Okay, but is the storm surge distributed equally across all of the hurricane?
No, it's going to be different as seen here in this projected map. You can see how even in this one area impacted by the hurricane, it differs the further inland you go or the further you are from the eye of the storm.
Isn't there one side of the storm which is more dangerous for storm surge than the other?
Yes.
Which side is that?
It is the northwest side, I believe, or it's the northeast.
Well, it's the northeast because the hurricane is spinning in which direction?
Clockwise.
Counterclockwise.
Yes, because we're northern hemisphere.
Yeah, counterclockwise because we're in the northern hemisphere. Cyclonic. And so the cyclonic winds are going to hit on the northeast side first. That's the dirty side of the storm. So that's what you don't want to be at. Okay, well, we'll move on. We're out of time. And so with the Seahorse people, please, you can stop sharing your screen from alcoholics and we'll go on to the Seahorse Cowboys. Oh, another presentation on hurricanes. Huh.
Okay, so we are the Seahorse Rodeo Cowboys. Our presentation is on hurricanes, including the basics, the devastation, and the future. In this presentation, we have Logan Tuna, Teresa Widensee, Cameron Battis, Grace Jones, Brock Law, and me, Emma Steiger. Okay, so just a little outline. What is a hurricane? Hurricanes are a type of tropical cyclone. A tropical cyclone is an organized rotating system of thunderstorms and clouds. Tropical cyclones are deemed hurricanes once they begin to sustain winds of at least 74 miles per hour. The most damage from hurricanes are caused by the flooding and the storm surges, as well as the high wind speeds. And due to the Coriolis effect, hurricanes rotate counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. And to the side here, we just have a couple pictures of hurricanes. The one at the bottom is a satellite image that shows like a satellite in it. All right, and then our outline. So first, the basics of hurricanes, including parts, formation, and classification. That will be talked about by Logan. And then we have the devastation that hurricanes cause, including impact on animals, which will be talked about by Teresa, and impact on humans will be talked about by Teresa, I'm sorry. And then impact on animals, as well as how to prepare, will be talked about by Cameron. And then lastly, we will have the ways hurricanes are changing, including how and why they're changing, which is talked about by Brock, and then the future of hurricanes, which is talked about by me, Emma. All right, go ahead, Logan.
All right, so the parts of the formation of a hurricane. So hurricane formation begins with an already developed local storm system. This storm system is then aided by a high water temperature, in turn creating convection in the atmosphere above the water. Water's latent heat of vaporization is very high, so it takes a lot of energy to break the bonds that hold water molecules together and evaporate the water into the atmosphere. The heat energy then gets released as the water recondenses as liquid. In a tropical cyclone, the condensation energy generates wind, not heat. Large tropical cyclones can generate up to 2.4 trillion kilowatts of power, which is equivalent to the amount of electrical energy used in the United States over 1 year. The increase of convection could then lead to thunderstorms or a small tropical depression, and then ultimately the projection of a tropical cyclone. These tropical cyclones typically form between 10 degrees and 25 degrees latitude in either hemisphere. Tropical cyclones occur in all tropical oceans, but are extremely rare in the equatorial South Atlantic. Although wind conditions would be favorable, the Coriolis effect closer to the equator is too weak to generate rotary motion, but it is strong enough to dictate the direction of flow. Due to the Coriolis force, cyclones originating in the southern hemisphere flow clockwise, and they flow counterclockwise in the northern hemisphere. As wind approaches the low pressure system from far away, there is rightward deflection of the approaching winds. Next slide, please. So the main parts of a hurricane include the eye wall, and the spiral rain bands. The eye of the hurricane is the very center of the storm. In the eye, there is a weak sinking motion as air is pulled into the eye wall at the surface. As the air subsides, it slightly compresses and warms. Therefore, temperatures at the center of a tropical cyclone are some 10 degrees higher than in other areas of the storm. Because warmer air can hold more moisture before condensation occurs, the eye of the cyclone usually has clear skies. The eye wall, a dense wall of thunderstorms surrounding the eye, contrasts the eye itself, as it contains the most intense winds and the heaviest rainfall. The high winds are driven by vast pressure changes near the eye, which creates a large pressure gradient force. The winds here actually reach their greatest speed at about 300 meters above the Earth's surface, because there is more friction closer to the surface of the Earth, which slows the winds down as you get closer. And at above 300 meters, they're weakened because of a slack in the horizontal pressure gradient force. When updrafts reach the upper boundary of the troposphere, the air flows outward. The Coriolis force deflects this outward flow, creating an anticyclonic circulation aloft, which is why horizontal circulation in the upper levels of a tropical cyclone is opposite to that of at the surface. In addition to deep convective cells surrounding the eye, there are often secondary cells arranged in bands around the center. The storm's outer rain bands containing the hurricane's force winds can extend from hundreds of miles. In some cases, the rain bands are stationary relative to the center of the moving storm, and in other cases, they seem to rotate around the center. Sometimes the bands in the eye are obscured by higher level clouds, making it difficult to track through satellite images from above. Next slide, please. Okay, hurricane classification. In the Northwest Pacific Ocean, tropical cyclones are known as typhoons. But if they develop in the Southern Hemisphere, South Pacific Ocean, and Indian Ocean, they are still referred to as tropical cyclones. A tropical cyclone is not deemed a hurricane until it reaches wind speeds of 74 miles per hour. Only about 50 tropical cyclones reach hurricane status every year. The strength of a hurricane depends on the air pressure. It follows that the lower the air pressure, the stronger the storm. The low pressure causes more air to rush in, therefore increasing the intensity of the storm. The Saffir-Simpson hurricane wind scale classifies the intensity of the storms from category 1, where wind speeds range from 74 to 95 miles per hour, to category 5, which contains winds up higher than 157 miles an hour. For reference, Hurricane Michael, a category 5 hurricane from 2018, was one of the most destructive storms in history. As far as the study of these storms, scientists are able to track the path of these through satellite imaging. NASA and other reputable space agencies have satellites in place specifically for tracking weather patterns and collecting data. They track things such as visible clouds and air circulation patterns, while radars measure rain, wind speeds, and precipitation. Infrared sensors can also detect vital temperature differences within the storm, as well as cloud heights. Long-term forecasting and tracking now allows meteorologists to predict how many hurricanes will take place in an upcoming season and to study trends and patterns in global climate.
So I'll be talking about how hurricanes impact humans. First, there's usually loss of life in every large hurricane. For an example, in 2018, Hurricane Michael killed at least 35 people. And in Hurricane Katrina, nearly 1,800 people died. Most of these deaths are highly attributed to storm surge and flooding, which are fast-moving and unpredictable. Hurricanes also impact many homes and businesses on the coast. Evacuation orders and property damage can lead to temporary displacement and unemployment. It may take years to rebuild and get back to normal after hurricane destruction. Not only does it take a long time to rebuild, it also costs a lot of money. Another impact hurricanes have on humans are federal and personal economic pressures. When hurricanes hit, people are left with thousands of dollars in damages, and due to this, many people living on the coast have flood and wind insurance. Here in this table, the top 5 costliest US hurricanes are shown. From least to greatest, there's Hurricane Irma, Sandy, Maria, Harvey, and Katrina, the costliest in 2005, which was $161 billion in damage. Lastly, hurricanes temporarily impair natural resources for humans. One example of this is forestries. In past seasons have shown that forest resources can be severely damaged after hurricanes and very often need time to recover and reforest. Next slide, please. All right, so I will be discussing the impact on animals. In addition to hurricanes impacting humans and their communities, they can also pose an environmental impact as well, especially for coastal habitats. So corals, dunes, beaches, and vegetation near the coast are all impacted severely with hurricanes and can be deeply affected by the aftermath. So just for example, wildlife can be displaced by storm surges, sending marine life ashore, or wind and rain can displace and harm wildlife on land. An example of that is saltwater intrusion from storm surges can cause brackish conditions for freshwater mammals and fish that will cause them to either have food shortages or just not be able to survive in their environment. As we can see on the top right, there's a photo of a shark that's been displaced by a hurricane. And on the bottom is pictures of corals that have been destroyed by winds and waves during a hurricane that will be damaging to the ocean ecosystem. And then at the top left, we have a photo from after Hurricane Andrew in 1992, where about 80% of the coastal habitat, the trees and brush, was destroyed by the hurricane, causing food shortages and habitat loss for many of those animals. Next slide, please. I will also be discussing how to prepare for the storm. So there are news updates for any storm. There's a hurricane advisory, watch, and warning. A hurricane advisory is the lowest on this scale. It's just that it is expected that hurricane conditions can cause inconveniences or could be hazardous. The next step is a hurricane watch, is when a tropical storm or hurricane is possible within 48 hours. And then the top one on here is the warning. It is when an expected tropical storm or hurricane will be within 36 hours. So what you can do to prepare for the storm is stay informed. There are many channels that will help you do this, like the National Weather Service and the National Oceanic and Atmospheric Administration. They will let you know of these advisories, watches, and warnings. You also can plan for evacuation. You should learn your community's evacuation plan. In addition for that, your local government or your state's government will let you know how to plan for that. And finally, to prepare for the hurricane, gather in advance the necessary supplies and items you will need to stay safe after the hurricane passes.
Right. So since the beginning of the satellite era, we have seen some concerning changes occur in hurricanes over the years. They are becoming more intense, their precipitation and wind speeds have increased, coastal regions are more vulnerable to storm surges, and the effective range of hurricanes has increased toward the poles. Next slide, please. So what's causing these changes? The cause can be summed up shortly as climate change, but this can be broken down into three main changes in the environment. As the Earth warms, ocean surface water temperatures are increasing as well. This leads to a higher input of energy, which in turn leads to higher energy output of the hurricanes, causing more intense storms. As global ocean temperatures increase, so too does the water in polar regions, making them more similar to tropical waters, which is where hurricanes form and thrive. The warming of polar waters has increased the effective range of hurricanes poleward, which has allowed them to get as far as Canada's Atlantic coast in recent years, like Hurricane Dorian in 2019. The final effect of climate change that is causing hurricanes to change is the melting of the ice caps. As the polar ice caps melt, sea levels begin to rise, providing more water to the hurricane, which allows larger and more dangerous storm surges to form and devastate coastal regions. And on the side there, I have some nice graphics explaining how sea surface temperature increase affects hurricanes. And then below that, I have one that shows how sea surface temperature has increased since 1901. Next slide.
Okay, so now I'm going to be talking about the future of hurricanes. So although hurricanes are a part of Earth's natural climate system, they cause a great amount of social, economic, and physical devastation. In the coming years, the effects of hurricanes will worsen as the average intensity of these storms will increase. Although we have seen an increase in the frequency of hurricanes in the past few years, for instance, in the late 1980s, we had 5 to 10 storms per year, but from 1995 to 2015, we went up to 15 to 25 per year. So although we have seen an increase, there's a lot of data saying that we will see an increase, but there's also a lot saying that we won't see any increase. But there does seem to be a general consensus that we will see the intensity of hurricanes increase, meaning that there will be more higher category storms, so more 4 to 5 category storms. And research has shown that this is because of anthropogenic climate change. In this case, anthropogenic means is used to describe that is which is unlikely to occur from natural variability alone. So yes, there are shifts in our climate, natural shifts in the climate, but there are things that humans are doing to contribute to that. So on the side here, I have some graphics just showing the first one on the top is showing an increase in higher category storms. So the red is showing category 4 storms and the black is showing category 5. So in the A part of it, the present day simulation, we see a lot of red in the northern hemisphere with just a few speckles of black here and there. And then we see some red and a lot of blue in the southern hemisphere. In the late 21st century, at the bottom there, we're seeing a lot more red speckles in the northern hemisphere, as well as just a lot more blue and red in general. Blues are just tropical storms in this case. But yeah, as we will see an increase in 4 to 5 category. And then in the bottom graphic, it is showing just a few different simulations, 27-year simulations of category 4 and 5 hurricanes. So this is kind of from a little bit ago, but in the left corner, we see how there were only 14 storms. Usually they're pretty low. We've got some 2s and 3s and 4s. And then in this other, to the top right, we see about 20 storms. We see a lot more red, I would say, and some blues as well. And then in the 28 storm one at the left bottom, we're seeing more black, definitely. It doesn't look like the rest of them have very much black, so we're seeing more category 5 storms. And then bottom right, although we are seeing 19 storms, which is less than the other 2, it is greater than that original present day 14 storms. Okay. And Teresa.
Okay. Now I'll be talking about recommendations to reduce hurricane intensity and overall damages. First, we need to try to mitigate human influence on the ocean. Pollution and greenhouse gases may lead to higher energy levels and warmer waters where hurricanes can form, and it's important to try to mitigate these influences. People must also recognize the probable risks during a hurricane. Potential flood risks is important. This bottom picture shows a flooded home in Houston after Hurricane Harvey, which was caused by heavy rainfall in flood zones. People must be prepared and fully aware of these risks. Also, infrastructure and construction close to the coast must be hurricane resilient and must be able to avoid flooding damage. Engineering, land use, and planning must be primarily used to build structures that minimize the damage from hurricanes. For an example, an example of this is elevated construction, which is much more flood resistant. Next slide, please. Another recommendation is to improve hurricane response strategies. In order to do this, scientists are finding ways to improve the forecasting and tracking of hurricanes. With improved technology, they will be able to see a hurricane's size, intensity, and path more clearly. One new satellite, which is called NASA's CubeSat Tempest-D, can show a 3D view of a hurricane. Its goal is to eventually provide high-resolution real-time storm cover. Can be used to improve the tracking of hurricanes or dropsondes. This device is shown in the picture. It has a parachute and is dropped from an aircraft over a storm and measures data like wind speed, wind direction, temperature, humidity, and pressure. It's essential for forecasting large and dangerous storms. These instruments help us to predict hurricanes and mitigate future damages. Next slide, please.
Okay, and just to summarize a few of our main points. So hurricanes are a type of tropical cyclone characterized by their strong winds. The main parts are the eye wall, and the outer rain bands. Hurricanes cause major devastation to humans, including loss of homes and businesses, and they cause federal and personal economic pressure. And hurricanes also cause major devastation to animal ecosystems, including habitat loss and food shortages. To the right, we see some pictures of just the damages that hurricanes can do, as well as a little diagram of just the parts of a hurricane. Continuing, the most important steps when prepping for a hurricane are staying informed, preparing for possible evacuation, and buying the necessary supplies. We have a graphic here by FEMA that just shows 3 of the important steps and some things that go with it. Hurricanes are changing because of rising ocean temperatures, which are due to climate change. And the future of hurricanes, we're seeing more frequent hurricanes, and we're seeing that they're moving more northward as the polar regions are becoming warmer. And hurricanes will grow more intense, which means that we are seeing more higher category storms, which means more destruction. And then here's our bibliography, which just has some good resources if you did want to learn more about this. And that's all. Thank you.
Okay, well, that was perfect. You finished exactly at 20 minutes. I'll ask a couple of questions. We're a little bit over time. I did want to ask about Hurricane Harvey. So why do you think Hurricane Harvey was so destructive? And there have been other hurricanes that have been like Harvey. And what would cause the different sort of destruction that we saw in Harvey? Anybody want to tackle that question?
Okay, I think it was just the wind speeds we were seeing and the amount of rainfall, just the conditions that come with hurricanes, including like storm surges, rainfall, which causes flooding, and the winds, which causes a lot of destruction to homes and stuff. So just the conditions that come with hurricanes just made it overall really devastating.
Yeah, and mainly like Harvey kind of stuck to the Gulf like for too long, which like it kind of didn't dissipate quick enough.
Yeah, so Harvey, during most of the time that it was so destructive, was not a hurricane at all. It was actually downgraded to a tropical storm. But instead of moving onshore the way most hurricanes do, the changes in the jet stream actually caused it to stall out right over Houston there. And the warm water in the Gulf of Mexico made it easier for the hurricane to evaporate massive quantities of water. So they had in excess of 50 inches of rain, over like a 24, 36-hour period, which is, some of the highest rainfall rates ever recorded. And there have been other examples of this, vastly increased rainfall due to these changing weather patterns. So I think that was something you might have brought out, because that definitely is something that's predicted in future storms, that we're going to have not just more frequent, not more intense storms, but the pattern of the storms may change so that they produce large amounts of rainfall, which is different from a storm surge. But I mean, I guess you have to consider it as a storm surge because it's flooding that occurs in conjunction with the hurricane. Okay, I thought that was overall a pretty good presentation. And so I'm going to stop the recording here. And if there are any questions from the class before we move on, if not, we'll see you all on Thursday. So just a minute, if anybody has any questions to bring up at the end, please speak up. Otherwise, I'll stop the recording and end the meeting right now. Any questions?
Professor, the quizzes that we send in for the presentations are also going to be on the final?
Not all of the quiz questions, but some selected questions. Yeah, there'd be too many.
Okay.
But yes, I will select questions. Some of the questions are very good, thoughtful, and they clearly present right and wrong answers, for multiple choice. So yes, some of those questions will definitely be on the final exam.
Thank you.
All right, everybody. Well, this is going on. We've got one more class meeting, and then we'll be moving on to the final. I want to change the due date for your to turn in the final extended abstract and slide deck. It would really help me if you've already presented and you're done, you've got your abstract where it is, go ahead and get that submitted to me and to Carrie, so we're not waiting to the last minute to grade any exam. So, please go ahead and submit your slides and your abstract, after you've gone ahead and presented, and then we'll grade that as soon as possible. All right, everybody, please be safe out there. Take care. Hopefully we don't have, well, I guess we'll see how we go in terms of when we can get back to normal. I think it'll be a long time, but you all be safe, and we'll talk again on Thursday. Bye now. Oh, one other thing, please, if you haven't already, respond to the questionnaire student evaluations. Really important to get your evaluations in to help us know how we're doing in this, with this changed format. So if you have any suggestions, and as always in these evaluations, written comments, suggesting things that we might improve or things that worked well, those are the most helpful, because that lets us, make the class better for future offerings. Okay, everybody, bye for now.